Tim, you have yesterday's note? Did you get yesterday's note?
Yep.
Good, okay. Did we have yesterday? We had a full house, didn't we? Wow, that didn't happen very often. I feel so popular today, less so. Okay, Michael, you'll lead yesterday's note, please. Yeah, so it's this one here, looking up trig ratios. So, as we discussed yesterday, we've been talking about the fact that, up till now you've always measured angles in degrees, which is just a whole circle cut into 3 different parts. But now we have 3 new ways to look at an angle. What are those 3 ways? Yeah.
Cosine, tangent, and sine.
Very good. Cosine, tangent, and sine. And instead of looking at the angle directly, how do we measure an angle in these cases? How do we actually figure out what the sine or the cosine or the tangent?
You use your opposite, adjacent,
And the other one?
hypotenuse.
Yeah, good. You struggled on the not the adjacent, which is the one people usually forget. So that's good.
I don't know why.
That's okay. That's great. So we said that one of the ways we can control the angle of a triangle is if we change how long those sides are. So we can measure an angle. And eventually I'm going to let you use your calculators. But for now, yesterday, what did I give you?
Big old chart.
A big old chart. Yeah. Because between 0 and 90, every angle lines up with one unique sine, one unique cosine. Yeah, absolutely. I mean, here's the nice thing. Next week when I let you use calculators, it's not going to be a magic black box for you. You're going to know what you're actually doing. You're going to know why it does what it does. Instead of... Yeah, we will. Don't you worry. So, yesterday, we did the first one together, and that leaves us with this second triangle, FED, right here. So here we go.
There was always a couple. Like for the last 2, there was 2.
Yeah, well, of course, because this table doesn't give you any decimals, right? So if you have 2 answers, that makes perfect sense. It means the real answer must be somewhere between them. And next week, when we're using our calculator, it will tell you very, very precisely. We'll be able to get an exact answer. But if I have a triangle like this, what's the first thing I have to do? Label. Okay. So let me ask you, how would I label this side down here? What would you call it?
That would be opposite.
Very good. How'd you get that?
Because across from the theta.
Very good. It's across from your unknown angle, across from theta. Good. All right, who can give me another side? Yeah? Is which one? Left or right? Very good. How'd you get that? Not the hypotenuse. Yeah, good. And so this is the hypotenuse, right? And I wrote right over top of the number because I'm clever like that. Good. So once we've got our triangle labeled, we want to find that angle theta. What do we do? Yeah. Now, by the way, eventually, will we do all 3 every time?
I told Roy that I did it just to get known with it.
Yeah. For today, I want you to do all 3 because we're practicing. We're just learning this skill. But any one of them would do it for you in a triangle like this because you know all 3 sides. Today, when we get looking at some questions, there'll be cases where you only know 2 sides and you have to pick which ratio you use carefully. We'll do lots of practice like that. So which ratio do you want to do first? Sine. Great. How do you find sine? Opposite over, oh, I missed my theta. Opposite over hypotenuse. Great. What is the opposite in this case? 14.1. And the hypotenuse? 16.7. When we did that on a calculator, what did we get? 0.844. And then if I want to know what theta, the angle is in degrees, what do I do with that number?
You find the number that's closest to it.
That's right. So
Your sine column.
that's right. So if we know that the sine is 0.844, we can look for that. Was it exactly any of them? No, in fact, it's... Did I get the wrong column? That's okay. I'm
I
wrong.
said like 33. I don't know.
Let's
where
take a look.
I was looking.
Oh, I know what you were looking at. You were looking at cosine. You just looked in the wrong column.
My cosine was-
That's okay.
I looked at-
I mean,
that was not it.
Well, let's take a look. Let's make sure I didn't make a mistake because I make a lot of mistakes, but that looks good. So the answer has to be between what? Between. Very good. So it's got to be between 57 and 58. Now, we will learn.
Oh, look, you guys have my pictures. Oh, we'll talk about this yesterday.
I don't believe it. All right. I don't want to do all three for both these. Let's do one more for this one. What other ratio could I do? Okay, tangent. And how do we calculate the tangent?
I'll do it over here.
Great. And in this case, that equals what?
14.1 over 9.0.
Great.
I got 5. I got 1.56.
When you did this?
I got
Yeah, that looks good.
1.56 there.
1.566? Great. And when you looked that up on your,
It was 57.
it was 57 exactly or pretty close?
Pretty close.
Great. So again, 57, 58 range. Good. Great. Is everyone comfortable if we don't do cos? The three should always agree. So if you ever do more than one and they don't agree, one of two things has happened. You've made a mistake, or as we discovered the other day in the assignment package, maybe
Maybe you just don't do assignments at 4 in the morning.
Maybe I made an impossible question again, which does happen. The impossible question,
Happens quite a bit.
yeah, I make randomized assignment packages for them, so everyone's questions are different. So I write some code that generates it. And the other day I gave them an assignment where question 3, and it was like a real in-depth one where they're drawing a triangle based on directions.
Yeah.
And it just didn't work. It was highly impossible. And I was unpopular. I was unpopular with.
I was getting a little mad at the question.
I am. Okay.
I was a little mad at the question on Friday.
Okay. So let's take a look at this triangle. We'll just do one ratio for this one. How would I label this triangle? You can give me a label. Megan, you got one for me? Which one's the opposite? Very good. Thank you very much. Michael, you got a label for me here?
No.
Yeah?
What do you want?
This triangle. Can you label one of the sides for me?
Okay. Can you do the opposite?
Yep.
The longest side 10.9 is hypotenuse, and the bottom one is the adjacent.
The adjacent. Thank you very much. All right. What ratio do we want to do here? You can pick any of the three.
Tangent.
Tangent? I see that. You've suggested it twice in a row now. Kendra, do you remember how we find tangent? I
know that.
must have missed when you changed your name to Kendra. I know you do that. Yeah, I bet. Kendra and not Dawson. What's the opposite in this case? Great. And the adjacent? Great. And when you did that math, what'd you get?
You were really going to trust my math.
Yeah, of course I am.
I didn't do this.
No problem. Did you do this? Do you have a number for me? 2.404? Great. And when we look that up, what do we get?
I
Yeah.
said,
I did that
I said 69, but
I
know.
said 68.
Well,
Well,
69,
let's
68,
take a look. 2.404.
I also did all three. I looked in between.
Yeah, that way.
Yeah, I would say our closest answer is 68, but I would say it's actually somewhere between
Well, because
67 and 68, but it could be a rounding issue. Did you use not tan, but one of the other ones?
Honestly, kind of stumped. Don't know what's happening.
Good. And again, when we get to using our calculators and looking these values up exactly, you won't have to pick a number. It'll tell you exactly the number. But I want you to know what looking it up feels like, so we have a real sense of what it is you're doing when you look up an angle, having had these decimals. You'll thank me later. It's like what I tell my children when I make them do math homework. They'll thank me later. They haven't thanked me yet, but one of these days.
It will.
Yeah, exactly. It's
They'll be on
coming,
your
right?
deathbed, holding their hands, they'll just be like, thank you.
You know, I really don't want to talk about math homework on my deathbed. I don't know. I haven't really spent a lot of time planning.
Yeah, you were right.
The only good thing you ever did for us was making us do math. All right. You know, I probably will talk about math on my deathbed, and that's kind of sad, isn't it? I don't think it's sad. I'll be
Well, I
proud
mean,
of
if
that.
you're a math teacher, it's not really sad.
No, I'd be proud of that.
If you weren't a math teacher, that might be a little sad.
Are you doing something? Oh, I will take it. Don't give it to me now or I'll lose
I
it.
got lazy on the last year, then took the Yeah.
All right. So today, I don't think it's going to take me all that long to teach this part. I think we'll probably get through the teaching in 5-10 minutes. And then you can get on to the, doing the math part, which is the interesting part. So I'll try to keep this side quick. So today, lesson 3.3, we're going to talk about how we can use these ratios not to find an angle. What if we already knew the angle, but didn't know one of the sides of a triangle? Can we still use trigonometry? Since I called the note finding the length of a side, the answer to my question is probably
No.
yes. The answer is probably yes. Yeah. So we're going to learn today how to find an unknown side using this. And remember, we can do this because we said the angle really depends on how long the sides are. Right? We said if we want to change the angle of a triangle,
Gotta make it bigger.
we can change just one side while keeping one of the other sides the same, right? So since the angle depends on how long the sides are, we can use the angle to figure out how long each side is. So we're going to write this a lot. I just want to on the top remind ourselves what the 3 trigonometric ratios are. What are they again? SOHCAHTOA, good. So that's the little word we use, right? We use that word to remember. So what's the first one? What does S stand for in SOHCAHTOA? Sine. And the sine of theta is calculated how? Yeah, by however long the opposite side is, divided by however long the hypotenuse is. Good. And again, we know this. It's review, but we're going to write down. What does the K stand for in SOHCAHTOA?
Cosine.
Cosine of theta. And what does, or not what does, how is it calculated? How do we calculate cosine?
Hypotenuse over adjacent over hypotenuse.
Very good. Yeah, that's exactly right. Even corrected yourself? Look at that. I always wait to be corrected by Dawson complaining about my mistakes. That's how I like to fix my mistakes. All right, and what is the last, sorry? Tangent, very good. And the tangent of theta, how do we calculate that?
Opposite over adjacent.
Thank you, Kendra.
You're awesome.
Kendra, you're
Your voice is getting deeper. Something's happening.
not that much deeper. So, like I should talk. Anyway, my voice was cracking so much yesterday when I was teaching my grade 9 class, and it was
Yeah,
really
my voice
embarrassing.
used to crack a lot.
I felt like I was about 14 again.
I thought my voice was getting deeper.
So, I have a triangle here. Mine is lovely in yellow. Yours is not. It's a much less appealing gray. But
We get
I
the
thought-
boring stuff.
I thought because I have to shut the lights out because this projector isn't very bright, it gets kind of dreary in here. I just thought the color. And then I was driving home yesterday, and there was a lady on the radio talking about, sort of how different cities have different kind of colorscapes. As you walk through different cities, every city kind of has its own characteristic colors that you tend to see a lot. If you ever walk around in Miami, you'll see lots of like pastel, teal colors.
Well,
and,
yeah, they're
they're
a very hot country.
Yeah, and if you go to like Washington D.C., everything's white marble and like brownstones. Whereas if you go to like San Francisco, everybody paints the houses like crazy colors. So they're talking about if you live in a dreary climate, a good way to make your house look inviting is to have like a nice yellow front door. And I thought, I could do like nice yellow triangles. Anyway, that's the end of my story.
Triangles, I like it.
Yeah, doesn't that look appealing? Doesn't that make you just want to solve for X?
Sure.
Okay.
Be careful what you go.
So let's take a look at this triangle. Who can tell me what we know? What do we know? Yeah, okay. So that was pretty clever. It's like honey. Yeah, so there's no y and there's no x. We don't know y, we don't know x. What do we know about the triangle? We don't know how long the side y is, we don't know how long the side x is, but we do know.
So you don't know your adjacent and opposite.
Oh, wow, you're way ahead of me then. You're right. If I were to label these,
You
This
know your opposite.
this 37. What is 37? That's my angle.
Theta.
So that's my theta. Very good. So we do know the opposite, but we don't know the adjacent, and we don't know the hypotenuse. There we go. Yeah, of course. Yeah, of course. So we have to find x and y. That's your task for this question. Now, are we going to find them both at once? No, we're going to find them one at a time. So we can pick whichever one we want to find first. Doesn't make a difference. You want to find y first. I think that sounds great. So I'm gonna like highlight that in green. We're gonna find y. We are going to use a trig ratio to do that. And now we have to ask ourselves a question. What side, in terms of opposite, hypotenuse, adjacent, what side am I looking for? If I'm finding y,
I use cosine.
okay, we'll get there. We'll get there. I like where you're going with this. We're trying to figure out which ratio we want to use. What side do we know? Do we know the opposite, the adjacent, or the hypotenuse?
So you're saying we should do more of the tangent.
Let's see. Let's see. Which side do we know? We know the opposite. Good. What side do we want to know?
You're actually getting me thinking on this.
Right. See? My God, it's like I get paid to do this.
Yeah.
All right. So we know the opposite, and we want to know, what are we looking for? We want to know the hypotenuse.
Okay.
Good. Geez, you two today, I asked Dawson a question, you answer. I asked you a question, Dawson answers.
I'm like, wait a second, what?
Is this one of these like Freaky Friday? Have you like switched bodies and nobody told me in some hilarious like?
Maybe. It's one of those sitcoms where the people don't know either.
Have you? Did you ever work at Fort Erie? Or did you ever spend much time at Fort Erie? Do you know Pat Sirianni?
Yeah.
Yeah. So Pat's a great guy. When I taught at Fort Erie, there was a teacher there who worked with student council, and every time they had an assembly, student council made an episode of a sitcom that they called Fest Life. So every time there was a school assembly, they'd put the next episode of these on, and they were really funny. They were usually like jokes about teachers and this or that. The only thing I ever did in it was run around looking for being paged to put my attendance in. But he'd kind of put a lot of inside jokes and things like this. But we had these two really bright kids who were both on student council there, and they did one episode one day about the fact that there was like a switch thing. So all these teachers switched bodies with students and things like that. But these two students, they switched bodies, and they were just so similar that nobody noticed, and that was the joke. Anyway.
So you have like a YouTube channel. I would like to follow and have your looking.
Oh, yeah, well, you can learn like all about grade 11 chemistry, all about grade 12 chemistry. You could teach yourself all of like math and science just right from your home computer.
I was thinking about doing that so I have to do math again next year.
Oh, dear God. So,
She's like there.
okay, so now what we have to do is we need to pick a ratio. Hello.
It tastes really
Can I give you this?
It doesn't taste.
Okay.
It doesn't taste like Kool-Aid.
Okay.
Oh, okay. Continue.
Okay, let's look here. We know the three trig ratios are sine, cosine, and tangent.
I was just about to ask what you mean by ratio.
Okay, so we need to pick either sine or cosine or tangent.
I'd say either cosine or tangent.
Well, let's take a look. We know the opposite. So we need to make sure that the one we pick has the opposite in it. Does that rule any one of them out, Michael?
Okay, so cosine you ruled out.
So cosine's ruled out for this part. Now, when I find the adjacent, maybe later on, but right now we can't use cosine because it doesn't have the opposite, and the opposite's what we know. Now, we also know that we want to find the hypotenuse. So the one we're going to use has to have the opposite, because that's what we know, and it has to have the hypotenuse, because that's what we want to know. And that gives us sine.
was way off.
That's okay. That thing you're feeling right now, that's called learning, right?
I don't think that's.
Where you don't know something,
It's more.
you have an idea.
More or less close to thinking.
No, not at all. All right? So we pick sine. Because it uses O and H. That's not the clearest sentence I've ever written. But we pick the ratio that has the side we know and the side we want to know. So I'm trying to keep this a little zoomed out so that Ms. Fortin can get caught up. I hope everyone can read that. I'll zoom in a bit.
Where is that bond thing that deals of the science?
Sorry, because. Yeah, it occurs to me that not everyone knows my little short forms that I use when I jot my own notes. Sorry about that.
I'd say that. See, I would say that's like black. Because everyone uses.
I see that as blue cheese.
Right, yes. There you go.
Actually, yeah, I kind of see it as blue cheese.
And OS is on side.
I was a line cook in a restaurant for 6 very challenging years of my life. And it is amazing how those letters stick with you. I still have a nightmare where the chip printer just keeps going and my grill is full and things are burning and people are yelling at me. It's very stressful.
Then you just gotta go out and be like, I run this place.
Okay, so we're going to set up the ratio. We're going to set up the ratio. Now, which ratio did we pick? Sine. So we're going to say that sine theta is equal to,
What is that last one? It's green.
it says we pick sine because it uses the opposite and the hypotenuse. So sine theta, and what does sine theta always equal? What over what? Opposite over hypotenuse. And now I'm going to go down below, so I have lots of room. I'm going to leave myself lots of room. And we're going to fill this in. And I can move what I write, so I'm going to give myself even more room. And we're going to fill this in with numbers. Now, what is our theta? 37. Could we know what the sine of 37 is? How could we find that? If only we had some large, obnoxious document that our teacher had written the day before.
Look
That,
on the chart.
yeah. We can go look
We have
up.
really handy on our test.
By then, you're going to be using your calculator. Though, believe it or not, I am going to put that on your test. And I'll tell you why later. So we're going to look this up. All right, so we're going to look up sine of 37 on our chart. And what do we find? So when we go to 37, what is the sine of 37? Very good. So we're going to use that number. So we're going to say 0.602. And then we also want to put opposite and hypotenuse in, if we know them. In this case, what is the opposite? 3.0, very good. And what is the hypotenuse? Yeah, we don't know it. It's y. Now, from last unit, we did a ton of practice, and you guys got great. This should almost look like something you did a lot of. What does it almost look like? A kind of question we did like a whole 2 days worth of practice on. And you guys got really good at them, and then there was a bunch on the test, and you guys did great on those. And then we did some of them to solve similar triangles. What does this... Let's go back to let's go back to last unit. Does it kind of look like that?
I like that last year.
So here we have a fraction equal to a fraction with an x in it, and we cross multiply to find the answer, right? Wouldn't it be nice if we could do that for this? What's wrong with this?
Oh, good.
It's not a fraction, right? How do you make that first number a fraction? Fraction means dividing. So if I want to make it a fraction without changing it, what could I divide by that doesn't change it? Yes, that's exactly right. We're going to make it a fraction. That's going to be the step to this thing. We're going to make it a fraction. Well, this is just like the last one. Now, this is right from last unit. Because now, how do we solve for y? Yeah, we multiply those. So we do 3.0 times 1. And then what goes on the bottom? I should use a different color. Great, I just erased my number. Oh, now I erased my y. I'm rewriting the y. Thank you for being patient with me. And the other way, we do like this. And what numbers are there? Yeah, 602. And of course, the y we don't put there because that's what we want to find, right? So we say y equals that. We just cross multiply. I didn't give you calculators today, did I?
We're all but done now? Are we done?
Yeah, no, I'm just-
So these are the one I would like to read that now. I would like to support creating the, I get a restraint order or something.
I mean, let's just go ahead and do that cross multiplication. I wrote way too big for this. I'm going to shrink all that.
What? No.
No, okay, that was the first one. Second round was actually this one.
Up there is broke.
What's it say? When in doubt, just press enter.
Oh, now I did that damn problem again. Oh, and
So it's the battery.
Oh, because you put 2 decimal places in. Oh. Right? That is decimal 602. You just accidentally hit decimal again instead of 0. Okay, so go ahead and do this in your calculator. Michael, I appreciate how chatty you are, but I want to see this math. I know you can do it.
Yeah. Okay.
What do we get? Very good. Good. By the way, the 1 decimal place, because you only have 1 decimal places on the other, what does that round to? Very good. So we're going to round that to 5.0 because we only have 2 decimal places on the other. So we're going to stick to 2 decimal places here. It's the science teacher in me. Magically inventing new decimals makes me feel like I'm going to get yelled at by my second-year chemistry professor. Okay, does that make sense? We set up the ratio. We make both sides a fraction because then it looks like a question we know how to do. We know how to cross multiply. I know you guys know how to cross multiply because you guys did amazingly on that last test. Right? I was proud of all of you. I legitimately was. It made my day. And that's, I'll tell you, it is so much nicer to mark things and see people doing well. It just feels good. When you mark things that's dismally bad, that feels less good.
because that means I will go back.
So now we just found y, and what does y equal? 5. Now we also have to find x. We now have 2 choices. How can I find x? One old way. Is there an old way you already know how you could find x now? Okay, definitely cosine. And that's what I'm going to have you use because I want you to get the practice. How else could you find x here now? You have a right angle triangle, you know 2 sides, you want to know the third? You could also use Pythagorean theorem. So in the next page, you're going to get some practice with Pythagorean theorem again. But for this one, I want to do another ratio example, just so we get the practice. So to find x, what ratio should we use? Either cosine or tangent. It does not make a difference which one you use. So which one do you like?
Tangent gives you a bigger number.
Tangent will give you a bigger number if that's nicer for you to work with. Okay, so do you want to use tangent? Oh, I just killed. Okay. Just trying to like landscape my page here so it's not such a disastrous mess. I'm not usually this messy. So to find x, we're going to use tangent this time. Could just as easily have used cosine. We just need to make sure we pick one that has the adjacent in it. So to find x, we'll use tan. So my first step again is going to be to set up my ratio. So in this case, if I'm choosing tangent, what does the tangent of theta equal? Tangent of theta always equals opposite over adjacent. Now, I want numbers in here. How do I find the actual number for the tangent of theta? How do I find the actual number for the tangent of theta? We know theta is 37 degrees.
So you look on that chart for 37.
Very good. And I'm just going to put a note on for that again, just to remind us where that number came from when we go look at this note later. We look it up. So who can look that up for me? What is the tangent of theta? Okay, guys. Michael, I'm like 3 minutes away from being done. But please don't. I get distracted. I can't think of two things at once, and now I'm all in like palace between here. Yeah. What is it? 0.754? Okay, let's take a look. So 0.754, and the way you found that was we took our theta, which is 37, and you looked on the table. And the tangent for that is 0.754. Good. So 0.754 equals what over what? Opposite over adjacent. What's the opposite? 3.0. And the adjacent is? X. Good. Now, I can't solve this question yet. What do I have to do to make this something that's familiar to us? Make it a fraction. Deanna, how do I make this a fraction? Do you remember? What did I do over here to make it a fraction? Very good. Yep, we just divide it by 1. Like that? Great. Very good. Now, how do I solve this? I would just say x equals what? How do I do this? Cross multiply. Good. So what do I put on top in this case? One and 3. Good. So, what did I just do? So these two, that was quite the sound effect I just made. So did anyone ever watch Dinosaur Train? I sounded vaguely like a baby pteranodon there.
There's a noise, yes.
It's a pretty great show. Dr. Scott, the paleontologist. We can sing the song later. I should focus now. All right, so on top we put 3.0 times 1, and what goes on the bottom here?
0.754.
Yeah, and there's no number for it to be multiplied by, right? So it'll just be by itself, 0.754.
I rounded it to 4.
Okay. And what do you get? You got like 3 point or 4 point
Yeah,
something?
I got like 3.97, but
And that rounds to 4.0. Beautiful. Because again, we're not going to magically invent decimals that didn't exist to begin with. The science teacher and me couldn't stand for that. That was great. Good job, guys. I want you to try the next one. And the next one, you don't have to find x both sides. I just want you to find the side x. Okay? So I'm going to have you do that while I go around and take a look. And then lesson time will be done. We'll just have some time to work on this. Or if you still owe me your assignment from the last couple days, you can work on that. Yeah, of course. But I want everyone working on this one. Once we have this question done? Yeah. So write it all. I want you to find it. Yep, do this what we did that. Here I go.
I just want to make sure I both of my headphones are quiet outside. I'll just go get more, but I couldn't break all of them.
I got those.
Programmer.
Yeah, not all done. And yes.
Yeah.
That I will admit that's quite funny. Now put it away. Okay, I want you to do that question. So what's the first step with all these triggers? Oh, what's the first thing you've done in every restaurant? Yeah, in science. We'll do that. Theta? Well, if I look up the letter theta, I could maybe know theta. That's right. So if I know the angle, then I'm probably just going to put the numbers in. But if it helps you, I would probably actually put some things.
get this. Once it's this time.
Did you see the last test? Show me the last test. Yeah, look at that,
You know what's like this?
right? And she drew me a picture. She made my night.
So what would you want to use? Do you want to use handwritten, sand? Let's use sand. Oh.
I had run out. Oh, I didn't show you my stickers. I made stickers with my face on them. People look. They pretend to be embarrassed by them, but I'm. That's good. But didn't I push? You're right. You're right. That's okay, because after finishing is how many sides? Well, sine is what over what? Okay, so will that let you answer this question? Okay, so you can pick side. What's the next one? Sine's not cool. Yeah, for that, give us a number and what we're looking for. Won't it? Then we'll give us numbers and what we're looking for. That's the way we want. So adjacent and hypotenuse. Which ratio is that? 10? Yes. Beautiful. Good job. Yeah. Yeah, just the end.
What are you doing?
Now we can get to the listen to number, right? So you get it. Listen, there'll be times. There'll be times. Not this time. But obviously you know that I love you doing what you're doing. Not impressed with me. I hear you're gonna have to like so let me ask you this. What ratio? You have to pick sine or cosine or tangent. Well, here's what I want you to do. Point at the side you know. Point at the side you're looking. And which two do you know? I know this one. Do I know anything about this? So I can't use that. So I need to use this one, and I need to find this one. Which ratio is going to make that? Well, what two sides is that? Yes. Yes, correct. Nice.
So, you know, that. We're stumped.
Now, I want you to think. Visually help. Now, how do you find this one? We know theta? You know, theta in degrees is 33. I don't want to say that. I want to be close to theta. I'm going to find that.
So what information do you have?
What angle do
What information do you have?
Well, done.
No. Which ones do we have?
So it is.
Done.
Where's the 33 going?
Yeah.
Here.
Yeah. Is it really comfortable if I put the lights back on? I feel like I'm ready to take a nap. You like them off?
Where's the angle?
Okay. I was like, Tim, I have like one page left to look at the test. I will get back to you today, I promise. I'll find you. Sorry, I left it sitting on my desk.
That's the answer.
Where's
Oh.
the angle going here?
I have no idea. I'm totally. Okay. We're all over this, right?
These are sideways. Not one of those things. The angle.
Nice.
Yeah.
Hey, remember that?
Yeah.
Put it here. So the theta is represents the angle. That's why.
I didn't know this professor used to give me 93 on everything I did, no matter what I handed in. And I once had a multiple choice test with him out of 20, and he gave me 93 on it. Figured that out.
This thing, like, how do you get that weird number? Like, you put it
Yeah.
on this, like,
It does not make sense.
I don't know what he's looking at. Where it's at. Good help.
Sorry.
Yes, very good. Very good. That's exactly right. You can do this one?
Oh.
Yeah.
Starting what again?
Yeah.
It's in Orlando.
Yeah.
I just realized, because you know how you do that?
Yeah.
Yeah, it's the little thing. Divided by, and yeah, and then just increase that. So great, and the users sitting on.
We're gonna look at this
Oh,
side.
yeah, to look that side up. Because you're right, that is totally changed. You're totally right. And these questions actually end up being nice cross multiplying questions, because that's always a one. And then I thought the X is always a one.
On that big giant chart, and we're gonna look at the cosine of 3 for you. Just got a big chart.
Yeah, that was fun.
Cosine for 33
Where'd
is
you get 33?
8.39. Or 0.839, sorry.
So you're gonna take that number. That is not enough.
Oh, you're way, can I check the other thing?
Oh, and then I,
Looks
well,
great.
that's it, modify something.
You cross multiply.
Okay. What'd you
How
get?
do you get that number?
Cosine, okay. Let's take a look. Cosine is.
Where's what I want? How do you look
Okay,
it up
so
though?
X
You have
over
one right there.
Oh, no, hang on, we're good. So you used the numbers for 5.
Yeah.
The ratio you actually needed was, yep, so you should have used 4. Because you know the opposite and you want to find the adjacent, so you should have picked.
It's better than that.
Get it? That's okay. Listen, which one is opposite and adjacent?
Oh, this one right now.
No. Adjacent, cosine is adjacent for the obvious.
Opposite and adjacent.
Where am I touching them?
Good. Set up with 10. Okay, but your process is good, just set up with 10, and you should be ready. Good. So give me one decimal. One decimal.
I don't even know how. that-
19 is
How
close
did
to.
you get these questions? Because I wasn't very good at these. I'll put this times this. Oh, wait, finish writing this one down. So number one, we have all of these. Equals 5.2.
Oh, you explain that. Okay, so this one. That's great. Good job. Good job. So now we run the kind of label them right. Yeah, label them.
No.
I didn't know you. I just. Going, yes. Yeah, you're right. You're good. Never. No, I didn't. You did right. It's okay. I heard my name. Who they hear from? Yes. So now, and I know you're good at this because you do all the time. You have fraction equal to a fraction with a variable in.
Orlando.
Speaking.
Michael Farrell in class,
He is, yeah.
and then to the office, hopefully.
Yeah, he sounds right.
I thought she was an asshole.
I got it in today. And yesterday.
So,
Oh, look at that. My clothes.
well, no, it's long.
This might be where I die.
Really have to go back.
This could be where you find me on Monday or next week. Okay, so. What do I find? Remember that? And the one on the top is the pair that doesn't have the X. The bottom is just the numbers, no X. You have the X, remember that? So go on the top. And I like to see that. I want you to hold on the bottom. Yeah, and you're totally like, this thing with these, that's always the one, and that's always the one. So it ends up being just one number on top and one number on top. Pick the one on top. So top would be 5.2. Means that X equals over, what's on the bottom?
Everybody forget?
Nope, the X is equal to 5.
And then I have smoked apple too.
Together.
That's why I tried to.
Unless you happen to remember 0.839 times 50. No, not so much.
Has it?
Oh, wait, I'm not gonna-
Well, that's okay.
Those I gave you now.
That's perfect.
Oh my god, another one?
That's great.
Oh
The only
my
thing I would say
god.
is like usually round.
Why are they so-
magically-
Suddenly, now that it's
So since we
2017,
have one decimal,
why the hell now are they so confused on what the hell they want to do?
Basically makes that up. 6.8.
They were fine up until grade 9.
That's great.
Is it like
Again, things feel-
part of a new trend or something? Once you get to grade 9, change how you want to feel about yourself? You want to be a guy or a girl?
I don't know.
It'll start to change.
Bears.
It's
So, this
Alexis.
deal.
Until they legally change their name.
So I'm gonna show you that in the done, okay? Okay?
Yeah.
I'm fine then.
But like, whatever you want to call it, it's all like post office, Snapchat.
And then it's already a map.
That's another one.
Yeah.
2.747 available in fraction equals
So whenever I go.
So you guys have change you.
That's
If I go around it, I'm
always
like,
gonna be one.
yeah, no, this is my friend Jake, and she says.
Yeah.
That's great.
She's like,
And like I'm looking at, does that number make sense?
I have to correct myself.
Of course, the only thing I'd say with all these numbers is, if this is 5.2, it's just one decimal, I would put this answer where. Very good. And if this is one
I
decimal.
remember Megan Jacqueline. Good, well anyways, within the first couple months of school last year, she changed her name like 5
I
times.
know.
It's like,
Are we talking about Jake?
no, Megan Jacqueline or Chase from last year, or no, what the hell is it? Nova.
Eventually, yeah. Yeah. If we're done with number two, yeah.
No.
Okay.
Now I know who you're talking about.
Okay. Has it? Oh, that's great. The only thing I'd say, all your answers are right, is if this only had one decimal, give me one decimal for it. And if this only had one decimal, round that. So this would round to. Very good. And this would round to. Perfect. Yeah, exactly right.
Wasn't her other one like Shane or something?
Hmm?
Her other one's like Shane or something?
Yeah, it was like Chase,
Oh, yeah.
Jace, there was like Noah, Nova. Yeah, I think it's David Nova.
I think I should change my name every day. Tomorrow I could be like
Please,
Mr.
can you please not.
Tomorrow I'll be like just Mr. Lando. Just short it down.
And then
My
Mr.
brain
Doe.
is so-
Mr. Doe. Could be happening.
No, like John.
Could be happening a little quicker than I'd like. So you guys have all seemed to have done great on this. I just want to make sure my notes are complete. So this top one here, how do we start? Well, but I saw you labeled it. So how did you label it? How did you label it? So across from the,
Opposite is like the very bottom.
very good. That's right. What else can you tell me?
X is
Very good. And
and
the adjacent. Very good. You guys are saying that well now, by the way. I appreciate that.
Jason,
Okay, now
Jason.
we have to pick our ratio. What ratio did we pick for this? And why did you pick it?
I picked cosine.
Okay, you tell me what one you picked.
cosine.
Cosine. Why did we pick it? Why did we pick cosine?
Because the adjacent had the measurement is where we need to find the side.
Excellent. Very good. Shh. Very, very good. So we would use cos theta. Kendra, what does cos always equal? Kendra, what does cos always equal?
I don't know.
Yes, you do. Yes, you do. And if you don't, switch to the front page. I said Kendra, not the other Kendra. This Kendra. The Kendra in this. You're talking about somebody who changes the name all the time. You decided today that your name is Kendra all of a sudden.
I'm just too cool.
Cos equals what over what? Always. Adjacent over? Very good. That's right. Okay, now, we know theta. Theta is 33. Can I look up its cos? Why the hell not, indeed? So we're going to look this up. So we're looking up 33, and we want to know its cosine, which is what? 0.839.
Yeah.
Good. So it's a 0. Oh, I don't want to be red. I like red. Red's a nice color, but I'd like it.
Okay.
Okay, and then what do I do on this side?
Put you put 5.2.
Very good. And on the bottom, how long is the hypotenuse?
X.
Very good. Just like that.
And then you add the 1.
And then I make this a fraction by putting a 1 there. Good. And then, yeah, once we've done that, it looks like a familiar question. What side's going to go on the top? I think you all did this right, but I just... 5.2 and 1 go on the top. And on the bottom, 0.839. And then there's no number with the x, so we don't have to worry about it. And when we plug that into our calculator, what do we get?
6.19.
Great, and I want that to 1 decimal, so that would be measured as 6.2. Very good. All right.
See what X is?
I got 6.2. Well, Deanna got 6.2, and I believe her.
I got 6.
Sorry? Oh, for the next one.
Yeah.
Okay, so for the next one, well, before you give me the number, how would I label these? Real quick. This 6.5 side is the opposite. This x is the very good. And down here, the hypotenuse. The
I think that's what I'm gonna say. The hypotenuse.
the hypotenuse. Okay, which side are we picking here?
Opposite and adjacent,
Opposite and adjacent?
which would be tan.
Very good. So we're going to pick the tangent of theta, and that is in what order? Opposite and adjacent. Which one goes where?
Opposite on top, adjacent on the bottom.
Very good. Opposite on top, adjacent on the bottom. And now when I go to actually put numbers in, how do I get tan theta? What am I going to have to do there?
You have to get to the big chart.
I have to go to the big number chart. I got to look it up. What do I get when I do that? The tan of theta, what is theta?
Theta.
Look up tan.
Is
Yeah, so tan 70, what did you get when you looked that up?
2.47.
2.47. And what does that give me on this side? Opposite is
6.5.
6.5. X is on the bottom. How do I make this something that's familiar to us?
crisscross,
Well, before I crisscross.
7 by 1.
Very good. Then,
then crisscross.
that's right. Great. Which one goes on top?
You're 6.5 divided, or not 6.
Hmm?
6.5 times 1.
Very good. And what goes on the bottom?
You're 2.47.
Very good. And then the X is up in front. X equals. Yes, ma'am.
The 2.47, is this supposed to be 2.7? Yeah.
Is it 747? Okay.
7.7.
I believe you. There we go. Is that correct? Sorry about that. I don't always hear well. All right. And when we do that in the calculator, what do we get?
2.4.
2.36, and we're going to round that to 2.4. Very good. Well done, guys. So here's, you want to know kind of the cool thing? What we did yesterday and what we did today amount to all the skills you actually need for this unit. Now, that doesn't mean we're done the unit. We're going to look at... Yes. Okay. That's going to be my number one goal for when my... Yes. That's... when am I going to write myself a note for that so I'll remember? When I put this online, I will look at the top and I will see that. Every day.
Oh, hi.
Are you talking to yourself now? Just think, you can go home and play that and then talk back. Do you want to have a little conversation with yourself? You can pre-record one side now, and then you can totally have the other half of the conversation. Oh, that would be great. And you'll have rewatched the lesson. I did, with my 3Us, they have a test today and they were kind of panicky. So I said I'd do an online help session. Yes, I was marking anyway. I had 7 to 10 p.m. last night set aside to mark. So I said I'll put a Google Hangout up online and you guys can log in if you want to ask me some questions. And they did, and it was fine. But I wasn't thinking, and I had the Hangout on my desktop computer and this computer.
Oh, God.
So I couldn't figure out what the problem was. But every time I'd talk, my voice would appear double. Like I'd say like, oh, hi, how can I help you, Andrew? And then like a quarter second later, hi, Andrew, how can I help you? And it was very distracting.
How long until you realize?
After I was done, after I'd helped several people. So everyone who logged on for help had to listen to me and like in double. Yeah, there you go. If it had been a long enough gap, the next person could have logged on, just answered the same question. So that's great. So what I want you to do is this. We are going to eventually go through every one of these questions. So that is what needs to be done. But if you haven't finished the first trig assignment, the first assignment of this unit, I want you to focus on that first. That one right there, the one where you did some drawing. So get that into me. And then once you've got that into me, then you can